As much as life has changed over the last year, you're still pretty busy, so consider convenient COVID-19 testing from Quest. Get the same tests hospitals use without a doctor visit. Simply order online, select from drive-through or at-home options, and get results sent securely to your phone or computer. It's a great fit for your busy life. With over 25 million COVID-19 tests processed, you can count on Quest. So order your test today at questcovid19.com. That's questcovid19.com. With Masterclass, you can learn from the world's best minds anytime, anywhere, at your own pace. Learn how to ace your opponent from Serena. Improve your writing skills with Neil Gaiman. Learn how to negotiate with Chris Voss. All right. Those were the courses I chose, but you'll have over 90 classes to make your own choice, and they're all taught by world-class instructors. Now, of course, the master instructor, Dr. Neil Degrasse Tyson, has a masterclass of his own on scientific thinking and communication, and we all know how important that is in these times. I'm not the only one who's benefiting from my masterclass. My brother is an avid tennis player, and I sent him the gift of a subscription so he could get schooled by Serena. Did I tell him that it was a part of my subscription? Well, let's just say the answer rhymes with ho, ho, ho. From learning how to write anything from a book to a screenplay, to communicating with your boss, to how to make dinner worthy of a Michelin star or just the best scrambled eggs this side of a jumpy chicken, there's a master class for you. I'm in the middle of a course on sex and communication because I'm good at one of those things. Masterclass is accessible on your phone, web, or smart TV. You can get an annual membership to Masterclass and give one to someone else for free. Get unlimited access to every Masterclass for you and a friend right now. Just go to masterclass.com/StarTalkRadio. That's masterclass.com/StarTalkRadio.
Welcome to StarTalk, your place in the universe where science and pop culture collide. StarTalk begins right now. This is StarTalk Live. Normally, we do this in a theater 4-5 times a year, but because of the coronavirus lockdown, this is virtual. And tonight's topic is climate change, the culture, the politics, the science, the denial, climate change. And we're bringing in some experts for that. And this evening is co-sponsored by Pocket Lab, a big supporter of teachers around the world, supplying tools for them to do right by the topics that they're teaching the students. And so with me, I've got Chuck Nice. As always, Chuck, how you doing?
Hey, what's happening, Neil?
So this is Climate Week. That's why we're doing it here and now, live on Facebook and YouTube. And of course, this is a collaboration with Pocket Lab. They've become our recent very good friends in this space. And so I think it's time to bring in our first guest. Okay, so first, a climate scientist, Catherine Hayhoe. She's been on StarTalk before because this is not a topic we haven't addressed. And she's the director of the Texas Tech University Climate Center, professor of political science, and a UN champion of the earth. I have to find out what that precisely means. And you said you've heard her TED Talk. Is that right?
Absolutely, yeah. UN.
Well, let's bring her on.
Yeah, go ahead. Yes. Hi.
There she goes, Catherine. Hello.
Hey.
Okay, you get the award for least interesting backdrop. Just want you to know.
It's very deliberate.
All right, so could you put us on
it that Catherine actually looks like she's calling in from a passport photo.
Well, I am Canadian.
Nice.
So just put us all on the same page when scientists speak of climate change. Just put us on the same page there. What do we mean when we say climate change?
We mean the change in the long-term average conditions of the planet. So our brains are wired to remember weather, a hot day, a snowy day, a crazy storm. That's like a single tree. Climate is like the forest. It's the average of weather over at least 20 to 30 years. And that's what's changing today. And that's why we can still have hot weather and cold weather, even while the entire planet is warming.
Very cool.
Yeah. So when did global warming change to climate change? When did that happen and why?
We scientists have always called it climate change. Global warming is more of a popular term. Global warming is a symptom of climate change. It's like you're running a fever, but the disease you have is not the fever. The fever is just the symptom. So the disease is climate change, and we're seeing an increase in the average temperature of the planet, but we're also seeing a lot of other things. Things are changing in the places where we live. We see wildfires are burning greater and greater area. We see hurricanes are getting bigger and stronger. We see that heavy rain events are getting more frequent and heat waves are getting more intense. And so personally, if I'm going to call it something, I usually call it global weirding.
Very nice.
Okay. That sounds like a new dance or something.
We should have gone with weird. That. Should have gone with that from the beginning. Would have definitely got a lot more people involved.
And so is there some climate change? People always want to blame today's weather on a climate change. So how do you advise people to think about weather versus climate in terms of what you're going to blame the anthropogenic factors on?
Mm-hmm. So weather is kind of like your mood, and climate is like your personality. You can be in a good mood or a bad mood, but long term, you're a certain type of person. At the same time, though, we know that climate change is affecting our weather, and here's how. So imagine you have a pair of dice, and you always have a chance of rolling a double six. That's an extreme weather event. But decade by decade, as the planet warms, it's as if it's sneaking in and taking another one of those another number and turning it into a 6, and then another one and turning it into a 7. And so pretty soon you're rolling all kinds of double 6s and even some 7s like you never used to before. And you're like, what is going on? That's climate change.
And that is.
Wait, but on your stereo system, can you turn it up to 11 though? That's really what people know.
So, in the case of climate change, yes, you can.
Yes, okay, because it is odd when people say, we haven't had floods this high since 1936. Well, you had floods that high in 1936 when no one was talking about climate change. So if the comparison to the highs today are always indexed to something long ago, what you're really saying is it's not that it's high specifically, but that we're having a lot of them. Like you said, someone is preloading the dice.
Yeah, another way to think about it is like a baseball player. They hit the occasional home run, and then they went on steroids, and they started to hit a lot more home runs. Okay. So it wasn't that a home run was unprecedented. It's just that their statistics changed, and that's what's happening with climate change.
Gotcha. And tell me about the Paris Accord, the Paris Agreement. You know, we get snippets of it. You know, in the United States, it's, are we part of it? Or are we not? We change leadership, and then someone undoes it. So where was it? Where has it been? Where was it? And where is it now? And what's our relationship to it?
Yes. So I was there. I was in Paris when this all happened. And what happened was almost every country in the entire world got together and agreed to limit global temperature change to at least 2 degrees Celsius, and if possible, 1.5. And just as a benchmark, we're already at 1 degree today. So that's where we were. And then pretty much every country in the world signed on. And then President Trump announced that he would be withdrawing the US from the agreement. But he can't officially do it until just before the election in November. So it hasn't actually happened yet. And if he does withdraw the US, they can go back in after just a couple more weeks. But here's the thing. It isn't just about federal government solving this problem. It is about organizations like cities and states, corporations, universities, tribal nations, religious denominations. And so they've all gotten together in the US, and organizations that represent almost half of US emissions have agreed that they're still in on the Paris Agreement. So it's not a 0 or 1. We're already, half of us are committed to be there. We just need the other half to come along. And for that, we need the federal government. But it isn't just the US. If you look globally at all the commitments all the countries have made, that only adds up to 3 degrees. We haven't got enough yet to get down to 2. It's kind of like a potluck dinner, and everybody's supposed to bring enough to feed everybody. Well, there isn't enough food on the table yet. So far, we're only going to hold global temperature to 3 degrees, not 2 degrees. So we don't just need the US, we need more from almost everyone else.
Yeah, but Catherine, at any given day, especially in dry climates, the temperature swings 20, 30, 40 degrees from mid-afternoon to just before sunrise. And so what can you tell people for them to be concerned about a mere 2-degree rise in the average?
I hear exactly what you're saying. And I've actually thought about how to explain this. And here's what I would say. The temperature of the planet is as stable as that of the human body. So if you add up all of the temperature around the whole world, it could be really cold one place, it could be really warm the other. But at the scale of the planet, it's as stable as the human body. And our human body temperature, 98 degrees, that's pretty warm. But if our body temperature goes up 1 degree Fahrenheit, or if it goes up almost 2 degrees Fahrenheit, which is 1 degree Celsius,
somebody stuck a thermometer in you and you're laying up in bed.
Exactly. And that's why this matters. The planet is running a fever. Yeah. And actually, let me tell you something really cool. The very first person to collect weather station data, because we do use weather stations all around the world, the very first person to collect all that data and show that the planet was warming was a British engineer called Guy Callender in 1938.
Wow. And he sounds like a game show host. That's very cool. I'm Guy Callender.
All right. So why? All right. So tell me precisely what is warming the planet. Okay. Let me be more precise than that. We know greenhouse gases trap solar energy and it remains in the atmosphere and the temperature goes up. What are the sources of this excess excess carbon dioxide, greenhouse gases?
Yes. So first of all, as you know, Neil, our planet already has a natural blanket of heat trapping gases that keeps our planet the perfect temperature for life. We'd be a frozen ball of ice if we didn't have this natural blanket. So what's the problem? The problem,
by the way, in fact, in my field, we call it snowball Earth.
Yes. Exactly.
times when the right amount of greenhouse was not happening.
No, it wasn't. So we're kind of like Goldilocks. We don't want too much of it because then we'd be like Venus. We don't want too little of it because then we'd be the snowball Earth. So the sun's energy actually goes mostly through this blanket, sort of like a window. The Earth heats up, the Earth gives off infrared or heat energy, and the blanket traps the heat energy, just like a blanket traps our body heat at night. Same way. So what's the problem? The problem is we are wrapping an extra blanket around the planet that it doesn't need. It's like somebody is sneaking into your room at night, which is sort of creepy when you think about it, and putting an extra blanket on you, and you wake up sweating.
No,
and
that's
you're
someone
like,
who loves you who puts on an extra blanket.
My grandma would always.
Grandma coming in with the crocheted blanket. Yes.
Yes, we had central heating in Canada, but she was convinced it didn't work. So she always came in every night with a blanket when I was at her house. So where is this blanket coming from? About 3/4 of it, 75%, is coming from digging up and burning fossil fuels. 75%. 25% of it is coming from land use change and agriculture, specifically deforestation and animal agriculture.
So deforestation, because plants take in carbon dioxide and they build themselves off it and give off oxygen. You take away plants, you're removing a sink or an absorbing factor in the carbon dioxide. That's correct?
Yes, but also when you burn them, it releases the carbon in the trees into the atmosphere too. So it's a double whammy.
Mm-hmm. Okay. But if you have a tree that had carbon dioxide that it took out of the air and then you burn the tree, it puts it back in, isn't that neutral?
It is, but if you're deforesting area and you're not putting the trees back again.
So now the tree is no longer scrubbing the atmosphere of carbon dioxide.
Yes. Right. So that's why I'm growing up in Canada. If you want to earn a lot of money in the summer to pay for university, you would go tree planting. Because some countries like Bhutan and like Canada, they tree plant like fiends. And what they're doing is they're cutting down the trees, but then they're replacing them. So the net impact on carbon is neutral. But what's happening is due to all the wildfires and due to all of the pests and beetles that are eating the trees, even in Canada, the forests have been a net source of carbon the last decade or more rather than a net sink.
Wait, you can't just throw in beetles out of nowhere. Beetles and insects. How does climate change affect our insect population?
And what is happening is there are beetles that eat trees and cold winters kill them off. So if they get killed off in the cold winter, you only have one generation of beetles every year. But if you have a really warm winter, it doesn't kill them off. So you have baby, parents, grandparents, and great-grandparent beetles eating the trees, and they eat millions of acres of trees. And so then when a wildfire starts, all the trees are dried up and they can burn up.
Oh, because they eat them, they kill them, and then
they become dry and Britain, and they actually become an accelerant at that point.
Yeah, a Kindle for it. The original meaning of the word Kindle, I think.
Yeah,
not a tablet.
Also, Tinder. That's another word.
and Tinder, right? But they all had previous meanings before the internet. But
it sounds like all of the problems that we're discussing here are exacerbating. The one problem becomes a domino to exacerbate another problem, which becomes this vicious circle. So it's a spiral downward. That's very scary.
So you're talking about a sort of a self-feeding loop.
Yeah.
Right? Yeah.
A self-amplifying feedback. We don't want to call it positive feedback because that sounds good, right? Like, I'll give you positive feedback. It's like, you did a great job. So we tend to call it self-amplifying or even a vicious cycle. And the worst vicious cycles are in the Arctic.
Yeah. All right. So what do you plan to do about this? No,
Catherine. What the hell is your problem, Catherine?
Well,
you are the UN hero of the planet.
You are one.
Right.
That's what I was doing last year.
What does that even mean? Wait, stop. What does it mean to be a UN hero? What does that mean?
Well, I showed up and I was expecting the cape.
So you showed up. That's all it took.
No, I was expecting the cape and the superpowers, and I did not get them. And I'm severely disappointed because I thought the whole deal was you got those and then you saved the planet, right?
Gotcha.
I mean, Captain Marvel?
Yeah. You don't have superpowers.
You're basically the Canadian Captain Marvel. So
I would like to be. And in fact, actually, I have a fantastic colleague who's based in New York. Her name is also Catherine, but she goes by Kate, and her last name is even Marvel. So I would be totally
happy.
Oh,
you know Kate Marvel. Yeah.
Yes. Yes, I know Kate well. I would be happy if she got the cape, too.
We've had her several times on StarTalk. But let's ask. So we want to do something about it because we don't want to warm the earth outside of our understandings of our civilization or capacity of civilization to accommodate it. So do we all become vegan? Do we stop having kids? Do we, what are some easy things, fast things? Because we're all lazy, So what's the simplest, easy thing to do?
Well, that is the number one question I started to get when I started to talk to people about climate change. And I was like, well, I'm a scientist. I don't fix this problem. I tell you how bad it is. But that's not satisfying because you can't have somebody tell you there's a problem and not tell you how to fix it. So I've thought about this for a really long time because we could each do everything we could. And that would just fix a fraction of the problem, just a fraction. 90 companies have produced 2/3 of heat trapping gas emissions since the dawn of the industrial era.
Okay.
But,
you want to pull the plug on 90 companies?
Not just that. We need system-wide change, and some of those companies are already starting to change thanks to pressure. Some of them might not change, and they're going to have to go the way of the horses and buggies. But we need system-wide change. But a system is made up of individuals, so that's why
we got to take a quick break. Okay. But when we come back in just moments, Catherine, I want you to pursue what it is that we need to do about climate change and the ways climate change is influencing our behavior. The way it should or isn't or can influence our behavior. So this is StarTalk Live.
Exploring the secrets of the cosmos is a fascinating pursuit, but have you discovered the vast and incredible potential of your own mind? Introducing Advanced Nootropic Formula from V-Thrive, the Vitamin Shop brand. Available at vitaminshop.com or your local Vitamin Shop store. This stimulant-free formula supports cognitive function, neuron development and repair, and brain-derived nootropic factor to promote the survival of existing neurons and encourage growth of new synapses. Non-GMO Advanced Nootropic Formula features clinically studied ingredients like Synapsa for peak cognitive performance, Cognizant for mental energy, focus, and attention, and clinically proven in extra so you can stay extra sharp. In fact, you may experience an improvement in alertness for up to 5 hours. As always, all V-Thrive, the Vitamin Shop brand products, are simply clean with no magnesium, stearate, stearic acid, or titanium dioxide. Advanced Nootropic Formula comes with a quality promise you can trust with ingredient purity and potency verified by independent third-party labs. The best part? It's on sale. Save 15% on purchases of $40 or more when you use code StarTalk at vitaminshop.com today. Again, that's 15% off purchases of $40 or more with code StarTalk on vitaminshop, SHOPPE.com to expand your mental universe today. Are you always taking care of your family? Do you often take care of others and not yourself? Well, now's the time to take care of yourself because you deserve it. Teladoc gives you access to licensed therapists to help you get back to feeling your best, to feeling like yourself again. Sometimes we don't know how much we need to talk to somebody. Take it from me personally. During the entire pandemic, I have had virtual sessions, and it has been such an incredible help. Now, with Teladoc, you can speak to a licensed therapist by phone or video. Therapy appointments are available 7 days a week from 7 a.m. to 9 p.m. local time. Hey, maybe you're feeling overwhelmed. Maybe you feel stressed or anxious or depressed or lonely, or you might be struggling with a family issue. Teladoc can help. No need to wait months to get a therapist. Teladoc is committed to facilitating great therapeutic matches, so they make it easy to change counselors if needed for free. Teladoc therapy is available through most insurance or employers, and individual plans are also available. Download the app or visit teladoc.com/StarTalk today to get started. TELADOC.com/StarTalk.
Hey, I'm Roy Hill Percival, and I support StarTalk on Patreon. Bringing the universe down to Earth, this is StarTalk with Neil Degrasse Tyson.
Welcome to segment 2 of StarTalk Live. We are in the virtual coronaverse right now. And this whole subject is on climate change. And I know a little bit about climate change, but not as much as any expert we would bring to the table, such as, who do we have? We've got Catherine Hayhoe. Thank you again, Catherine. And your Canadian accent is charming, let me just say. I know you're trying to hide it, but you can't. It's there for all of us to hear. But tell me something. How realistic is it to just simply change everybody's behavior?
Well, the first thing we have to change is not our behavior. The first thing we have to change is the way we think about the problem. Because it turns out, even though the headlines are all about people who reject science, when you actually look at the polling data, our real problem is that we don't think it matters to us and we don't think we can fix it. So that is why I have become absolutely convinced, after years and years of working in this, that the number one thing anybody can do is use their voice to talk about why it matters to us in the places where we live in ways that matter to us as people, and what we can do to fix it, which includes individual solutions like step on the carbon scale, measure your carbon footprint, figure out things you can do. But talk about how big corporations are going carbon neutral, like Microsoft and even Walmart and Apple. Talk about how cities are cutting their carbon emissions and meeting the Paris Agreement targets, like the city of Houston, where all of the big oil and gas companies live. Talk about how clean energy is revolutionizing the lives of poor people who don't have access to affordable electricity. Talk about how carbon farming puts carbon back in the soil, increases our soil health and our yields, and helps farmers be part of the solution. Use your voice to advocate for change at your school, at your place of work, at your organization, at your city, in your family. Using our voice is the most powerful thing we can do.
All right, so that's hopeful, and that's what we're doing here, right? With this StarTalk Live, featuring your voice, the Canadian Captain Marvel, as you are. Tell us the fact that fewer people are traveling now, the coronavirus lockdown, what has that done to the climate?
So it has reduced our emissions. In April, global carbon emissions dropped by 17% around the whole world, and they dropped by 25% earlier in China as the lockdown happened there first. And they're still a little bit lower than average because people aren't flying. That's great news. But as the lockdown passes, they're just starting to go right back up to where they were.
Oh, well, you don't think there's some habits that we've accumulated? Because it's way easier to do this virtually than for everybody to get up and get in a car and go to a theater. I mean, do you think there'll be some lingering bits of this that we keep?
I think that there definitely will be. But the bulk of it was industry, not you and I flying or traveling. That's only about 3% of total emissions. Here's the positive thing, though. To meet the Paris target, which we were talking about before, we have to reduce our global carbon emissions about 45% by 2030. And that sounded like an almost impossible goal last year. Well, you know what? We got almost halfway there in 3 weeks in April.
Right.
Okay. So that's it's, as they say in math, it's an existence proof. It's,
Right.
oh my gosh, you think we can't do it? We kind of already did.
Yeah,
At least part of
we
it.
had a proof of concept.
A proof of concept.
Concept.
Exactly. And
But emissions went back up again. So we just have to realize that we can do it. We can bring them back down permanently, not temporarily.
So with respect to what you were talking about with all of us using our voice, which I think is excellent. I think the Yale Climate Communication Study said that somewhere around 54% of people basically say they don't talk about it at all. They just don't even ever talk about it. So it's extremely powerful. But don't you also think that if we are doing something personally, that makes you vested in the problem? And being vested in the problem makes you want to see other people take action. And it also makes you want to hold corporations and leaders, authorities, accountable.
Yes, absolutely. So the social science has found that our sense of efficacy, in other words, if we feel empowered to act, that has a tremendous impact. And also even our sense of righteous anger. Look, I'm doing everything I can, and look at you, you're doing nothing.
I forgot such a term exists, righteous anger. That's like good trouble. It's one of those kind of things.
I hear it every Saturday when I'm laying on the couch.
What? Get out and mow the lawn.
Exactly. Look, I'm doing everything I can. I got to do everything around here. I'm doing everything. Go ahead.
Let's talk Chuck down off the ledge right there. So, Catherine, tell me about the wildfires that devastated Australia recently, and of course are doing so much damage in California.
So wildfires are one of these things we talked about where we're loading the dice. We've always had wildfires. In the US, most of them are human ignition. Most are accidental, not arson, just to be clear. And up in Canada and Alaska, they're mostly
just human ignition is not always malevolent, is what you're saying.
No, only 7% of the big fires in California were actual deliberate arson. Most of them were, as we now know, gender reveal pyrotechnics gone wrong, or people dumping burning trash into dry brush, or just having something plugged in the shed that shorted out and started the shed on fire, or power lines sparking. That's what starts most of the wildfires.
Okay, right. Didn't know that. So can you trace a thread from the wildfires to climate change?
Absolutely. Once they start, they're burning greater area. And the reason why they're burning greater area is because the vegetation is dried out. The difference is, imagine you throw a match on a pile of pretty green wood. What happens? Then imagine you throw the same size match on a pile of bone dry kindling. What happens? A conflagration happens. That's the difference between climate change versus not climate change.
Wow.
All right. So I'm still trying to figure something out here. If you just say things dried out, climate change, they dried out. Aren't there places that are getting more rain than ever before? Tell that to a place that just had a huge flood. So we are simultaneously, as a scientific community, saying, yep, it's dry over there, that's climate change. Yep, it's wet over there, that's climate change. And so people, I don't think they have a sense of some directed phenomenon that is itself increasing. So how do you reconcile that?
You're absolutely right. And the point of connection, the invisible point of connection, is the fact that warmer
air... Invisible?
Invisible.
Special glasses to see it. Okay.
No, just physics.
But scientists said, there's this invisible thing. You just got to believe me.
Right. No, we can measure it. We just can't see it.
Okay.
It's the fact that the warmer the atmosphere, the more water vapor it can hold. So in other words, the warmer it gets, the more it dries out our soils. And in dry areas like California, our vegetation. But when a storm comes along, there's more water vapor up there for that storm to pick up and dump on us. So in a place that gets lots of storms, they're getting a lot of heavy rainfall events. In a place where they don't get storms, all that water is evaporating and it's just being transported out of the region, leaving it drier than it would before. It's the exact same mechanism in both cases.
So these are related phenomena, the flooding and the droughts.
Yes.
Okay. And tell me about a sea level rise, because that's anytime I'm asked about climate change, that's what I think about the most, because most of the world's great cities are on the water's edge, historically, of course, for commerce and transportation and irrigation and the like, on rivers, for example. So sea level rise, how does climate change give you that? And who gets affected first?
Mm-hmm. So remember we talked about how we're wrapping an extra blanket around the planet that's trapping more
Grandma's
heat.
doing that. Yeah.
Yes. Over 90% of the heat being trapped by that blanket is going into the ocean. So when we're using thermometers to measure global air temperature, global warming, we are literally measuring the tip of the iceberg, and 93% of that iceberg is under the ocean.
Okay, just to be clear, you're talking about the heat energy, not the temperature. So if the ocean goes up by a fraction of a degree, much smaller than 2 degrees Celsius, that is an enormous amount of heat energy as a repository. Is that correct?
Exajoules. It means a lot of heat.
Exajoules. Excuse me. Exa as in the metric prefix exa.
Yes.
Joules as in the unit of energy. Thank you. Okay. I thought that was a new hip word that I didn't know about. Okay.
Yes. It's what all the kids are using to bake. it's the newest baking.
Okay. So there's kilo, mega, giga, exa. These are the metric prefixes, and there you go. Okay.
Yeah, giga and peta. So
Chuck Liu, your buddy, another astrophysicist, did a calculation that I'm going to screw up, so I don't want to say it, but he did the calculation of the warming of the oceans, how much energy they are holding, and it ended up being like, 100 atomic bombs, the equivalent of something like that.
What he did was he calculated, and I was going to verify this so that we can then go public with that number. Generally, you do that when you're scientists.
But I'm not a scientist, and you guys were arguing about it, so now I could just say it.
No, I'm just saying. So you can ask, how many atomic bombs would you have to detonate in the atmosphere to raise the temperature 2 degrees, as we have done, or we raised it 1 degree? What is that? And then, but we know atomic bombs, and everything else feels a little more sort of nebulous. So Catherine, in your business of bringing this to the public, you are just chock full of examples such as that, right? Because otherwise people can't wrap their head around the pure science typically that would otherwise be delivered.
No, we can't. We're not used to processing numbers like that, like 10 to the 21. What does that even mean?
Mm-hmm,
but why it matters, though, is because...
Wait, 10 to 21, that's how many gigawatts was in the flux capacitor. Everybody knows that.
God. What is wrong with you?
10 to the 21 gigawatts.
10 to the 21 gigawatts.
Yeah, it was actually gigawatts, but they said gigawatts because it's a movie, but that's fine. Wait, so let me ask another thing, Kevin. Some decades ago, one of the News Weekly magazines, back when people read things on paper, it had a headline, Ice Age coming. Mm-hmm. Okay. So tell me about these calculations that talked about ice ages, either in the past that would be imminent, or ice ages that might have been scheduled for the future and now will be delayed. Mm-hmm. Isn't that a good thing?
Yes, because we humans don't like it too cold or too hot. We like it just right. So in celestial mechanics class, which you probably took too, we learned about the orbital cycles of the Earth's orbit around the sun, and how they alter the way that the sun's energy falls on the Earth. And those are actually responsible for the ice ages, or what we scientists call the glacial maxima, and then the warm periods like we're in today. But because they are predictable, we can calculate where we are on that cycle. And here's where we are.
Oh, this is good.
Yes.
Oh, this is good. I love this part.
All right. This is the end of the mystery novel. Right here.
Here's where we are on this. Okay. Go.
All
we
right.
can take it. Bring it on.
We know that there was an ice age about 20,000 years ago. We know that it ended when a rodent went looking for an acorn and broke off a chunk of ice.
That's exactly what happened in the movie Ice Age. That is a documentary. Just
right.
so you know.
And you were probably there filming it, right?
I did have a cameo in Ice Age 5. Just so you know. I have a cameo in Ice Age 5. So I have to quickly tell you, one of the reviews of Ice Age 5 was, it said, "This is evidence that it's about time the franchise goes extinct." So there hasn't been an Ice Age 6.
I'm sorry.
So anyhow, back to, go. Right. Okay. So where are we on this cycle?
It was an ice age. We got warmer. Warming peaked about 6,000 to 8,000 years ago, right around the dawn of human civilization.
And agriculture even.
And agriculture, because we had the perfect climatic conditions. And then since then, temperature was very, very gradually slowing and cooling, very gradually. But agriculture and deforestation had pretty much stabilized it. So we had pretty much hit the sweet spot. And then the Industrial Revolution happened and we're going straight in the opposite direction. So the official conclusion is that the next glacial maximum would have happened in about 1,500 years, give or take a few hundred years. But in fact, we have indefinitely delayed it for not just thousands, but probably tens of thousands of years. And not only are we want to be stable, but we're not stable. We are headed in the other direction faster than any time in the history of human civilization on this planet.
So
Okay,
right
that's
now, we should be in a cooling period, is what you're saying.
Yes, you said.
We should be going down.
That's what she's saying. So yeah, tell that to LA when it was 120 degrees a couple of weeks ago. So what was it in Pasadena? Somewhere in the valley. So let me ask you. I leapfrogged over one of my questions, which was about sea level rise. Could you just tell me is it just melting of land glaciers? Is that all that's happening there?
Right. So about half of sea level rise is because warmer water takes up more space. And all of that extra heat is going into the ocean. The other half is the melting of land-based ice, not Arctic sea ice, because Arctic sea ice is already sitting on the water, like ice cubes in your glass. When the ice cubes melt, your glass doesn't overflow. But what's happening now is that sea level is rising twice as fast as when the satellite observations began 25 years ago. And that is because Greenland and Antarctica are melting much faster than they used to be. And the reason we care about it, like you said, is because 2/3 of the largest cities in the world are located within just a few feet or a meter of sea level. And about 700 million people live in the low elevation coastal zone.
So we just have to pick up cities and move them inland, and then that's all.
It's like a Superman movie. Just, it's like, hey, just buy property in Camden, New Jersey, instead of the Jersey shoreline, because that's going to be beachfront property one day.
You're talking about Superman, the original.
Was that the original movie?
Yeah, you're going way back, Chuck.
I don't know. It was Lex Luthor. That's all I remember.
Lex Luthor's in more than one of them.
Yeah,
He's a recurring.
Yeah, they're all
mastermind.
one movie to me. They're all one movie to me.
It's all one movie.
Wow.
So, what are the first? So, cities will obviously get hit, but I read about whole countries or land masses in the South Pacific or in the Western Pacific region of the world, where whole countries are just a few feet above sea level. So they'll just be gone if this continues.
Yes, and they're already trying to immigrate, but unfortunately, climate refugee is not an official designation for a refugee under the United Nations.
You work for the UN, change it.
I don't.
You're a card-carrying UN person?
They didn't give me a card. I'm telling you, no cape, no card, no superpowers.
No superpowers.
Big piece of glass. Big, large piece of glass. That's it. Unfortunately, New Zealand, for example, is taking a handful of people a year. They have a quota, but they're not taking nearly enough people to move the entire population. And even so, losing your country. Even if you could transport your entire family, which most people are not yet able to do, even if you could transport your whole community, you're still losing your country. And that is something that's part of you. And so our choices absolutely matter today more than ever, and we can make a difference. And one person truly can be that agent of change.
Wow.
Okay, Chuck, didn't you just say we have to all stop having kids and become vegans? You just said that.
I am all about that. You do not have to tell me not to have any children. Believe me, I am so on that train. I'm the
Chuck has 3 kids, by the way.
I'm the conductor of that train.
No. So Catherine, your comments are wise and sage, and so there is some hope, even if it's not unfolding on the time scale that we seek. Mm-hmm. Perhaps it'll. Maybe we need a few more disasters to make people sit up a little higher in their chairs, perhaps, because we tend to be better at reacting to a problem than preventing one in advance, I think, the history of American behavior in the world. So, but okay, because you're on the front lines. And if you tell us to have hope, I don't know who else to believe but you.
Active hope. Not just passive, it'll all turn out okay in the end, because it won't if that's the type of hope we have. We have to have active, realistic hope.
None of that Jesse Jackson hope.
Keep hope alive.
Keep hope alive. I'll make a rhyme, and then it'll be time to keep hope alive. Yeah. None of that. None of that.
So
we want
what
real
you're saying, Catherine, is because I don't like the word hope, because it's what you express when you confess that you're not in control.
Mm-hmm.
Oh, I just hope. But so the fact that you've now put a nuance on it, there's passive hope, which is what I just described, and active hope. I have hope that this will change, and I'm doing something to enable that.
Yes.
We will end segment 2 on that positive thought by Catherine. Catherine, it's a delight to have you again on StarTalk. We will continue to reach for you because this has not ended. And when you do get a card carrying UN ID, tell us. Then then we can hold you to it with whatever UN says. You go back and read in the Riot Act.
Or Catherine, don't worry. Just email me. I know some people that can make you one.
Mm-hmm.
Yeah.
Oh, to make her. Chuck, you got people like that? I got different kind of people. You got people. All right, Catherine, thanks for joining StarTalk Live.
Thank you for having me. I'm going to visit you all on Facebook and drop a few links into the chat if people want more.
Definitely do so. All right.
So you're ready to earn your degree, but you need a university that works with your schedule. Well, WGU and their programs are built to be flexible. WGU offers a quality degree program that's affordable and even makes it possible to graduate faster. Plus, you can earn a respected bachelor's or master's degree for under $8,700 per year, fees included. That's right, you heard me. That is the correct, $8,700 per year. Let your experience and dedication help you earn your degree faster. See what WGU's competency-based programs can offer you. With no set login times and 24/7 access to most coursework, you can really earn a respected bachelor's or master's degree on your own schedule. The low tuition rate covers as many courses as you can complete each term. That means the faster you learn, the more you'll save. Get your $65 application fee waived at wgu.edu/StarTalk. That's wgu.edu/StarTalk for your $65 application fee. Poof, gone, waived. With Masterclass, you can learn from the world's best minds anytime, anywhere, at your own pace. Learn how to ace your opponent from Serena. Improve your writing skills with Neil Gaiman. Learn how to negotiate with Chris Voss. All right. Those were the courses I chose, but you'll have over 90 classes to make your own choice, and they're all taught by world-class instructors. Now, of course, the master instructor, Dr. Neil Degrasse Tyson, has a masterclass of his own on scientific thinking and communication, and we all know how important that is in these times. I'm not the only one who's benefiting from my masterclass. My brother is an avid tennis player, and I sent him the gift of a subscription so he could get schooled by Serena. Did I tell him that it was a part of my subscription? Well, let's just say the answer rhymes with ho, ho, ho. From learning how to write anything from a book to a screenplay, to communicating with your boss, to how to make dinner worthy of a Michelin star, or just the best scrambled eggs this side of a jumpy chicken, there's a master class for you. I'm in the middle of a course on sex and communication because I'm good at one of those things. Masterclass is accessible on your phone, web, or smart TV. You can get an annual membership to Masterclass and give one to someone else for free. Get unlimited access to every Masterclass for you and a friend right now. Just go to masterclass.com/StarTalkRadio. That's masterclass.com/StarTalkRadio. Hey, it's time to give a Patreon shout out to the following Patreon patrons: Brennan Russ and Tony Maruli. Guys, we are so appreciative for your gravity assist as we make our way across the cosmos. Thank you so much. Without you, we couldn't do this show. And for anyone listening who would like their very own Patreon shout out, please go to patreon.com/StarTalkRadio and support us.
This is StarTalk Live. We're talking about the science of climate, the sociology of people's reaction to climate change, all of the above. And we're in collaboration with Pocket Lab, who helps us bring this to you live on Facebook and where else are we streaming? Facebook and
YouTube.
Of course. YouTube, of course. So coming into this segment, we're going to talk about climate chemistry and citizen science. And who's going to join us for that? Because I know a little bit, but not enough like the experts know. Let's bring in Peter Mahaffey. Peter, welcome back to StarTalk.
It's fabulous to be here, Neil. Chuck,
excellent. You're professor of chemistry at King's University in Alberta, Canada.
That's right.
Co-director of the King Center for Visualization and Science.
That's right.
And with a special focus on climate change, science, and awareness. You're the guy. If all this fails, it's your fault. If the attempt to change the world, because that's your title. That's on your business card.
Well, people have been blaming chemists for a long time, Neil, so lay it on.
So through the lens of a chemist, how do you think about and study climate change?
Yeah, that's a great question. Your audience is probably sitting there thinking, you're bringing a chemist on. What do chemists do? Well, they bring us toxic substances and pollutants and smoke coming out of exhausts. But I want to...
No, Peter, some of my best friends are made of chemicals. Okay, I don't know about you, but that's true for me.
Yeah, I want to plant a different image in the minds of your listeners and viewers. And I think of chemists as caretakers or stewards of matter and energy. And think about climate and climate change. Climate is regulated by matter and energy flowing through our atmosphere, cryosphere, oceans, and land. And chemists transform and analyze substances. We understand the flow of energy and chemical reactions and processes. So even though chemists don't pay nearly enough attention to that, climate change is right in our wheelhouse. And we need to both talk about it a lot more, as Catherine Hayhoe was saying. We also need to do a lot more about it. Let me give you an example. Everybody knows about carbon dioxide, right? Carbon dioxide formed from fossil fuels that were laid down maybe hundreds of millions of years ago. They've been there, and now in the last 250 years, we've extracted them at dramatic rates, and we're burning them, we're making CO2. Simple combustion reaction. And that's changing the energy of our planet in a short period of time. So that's chemistry that we understand and control, and it makes our life a lot better. But there's other chemistry too. There's greenhouse gases like methane and nitrous oxide and fluorinated gases. And physicists pay attention to isotopes in Antarctic ice that tell us what the temperature was a long time ago. And the best of all of this is that knowledge is now followed by the things that chemistry is doing at the forefront to develop new technologies to tackle climate change.
Okay, that means you can help us here. You're not just some chemist in a lab. Even though you know what's going on, you can actually be inventive and innovative to help this cause.
That's right. It's all about understanding so that we can do something about it. And then it's helping to provide the materials and reactions and new ways of thinking about transforming materials in order to mitigate climate change. And, there's new carriers for fuel, hydrogen and ammonia. There's fuel cells. There's the materials for solar cells and wind turbines. Chemists are working hard to create new ways of fixing nitrogen to feed the world.
Chuck, when Peter started talking, when he said, we command all of matter and energy. That was like the beginning of a superhero movie.
Well, basically, yeah.
He's somebody's nemesis, superhero nemesis in the making here.
If you think about it, chemists are Thanos. I mean, that's basically what they are. Don't let Peter snap at you.
I love the metaphor, Neil, of caretakers or stewards, right? We have these powerful tools, and we need to learn how to use them in a way that's green and sustainable and helps to build a better future for people and for our planet.
So what do you think in terms of, as you said, chemical companies may be seen as part of the problem, and we've had this conversation where you say chemical companies make what people demand. So, we're part of that problem too. But can they be part of the solution, and how would that be? Is there a...
What would that look like?
Yeah, what would that look like if we were to use chemistry as a way out?
Yeah, absolutely. And there's a huge change happening.
Wait, can I just butt in for a sec? Since it's not often I'm in arm's reach of a chemist, just before you answer that question.
I'll back off a little bit.
Don't let him near your neck, Peter. Don't let him near your neck.
Could you just list for me the greenhouse gases that are in the atmosphere and that exist so that I have a full understanding? Because when you come at us and say, here's here's what we can do to fix this or that. Presumably, some solutions are best for some greenhouse gases relative to others. So just give me that quick inventory.
Yeah, for sure. The only one that gets any airplay is carbon dioxide, right? And it's all about CO2. And that's for good reason. It's the most important greenhouse gas, and it's something that we can do a lot about, and we're doing a lot about. But right behind that, Neil, are methane gas, CH4. There's nitrous oxide, laughing gas. Who would have thought that's a major contributor to climate change? And then
where does that come from?
And
So-
why can't I get more of that in my life?
it's,
and you talk about methane. This is like cow flatulence, right?
that's right. That's a contributor, methane. One of the contributors are agriculture, including intensive agriculture. But methane comes from anaerobic fermentation, the stuff that happens in rice fields and paddies. It comes from landfills.
Termites too.
Termites produce large amounts of methane, oil and gas operations that aren't
My
really tightly
Uncle
controlled.
Daryl. Uncle
And
Daryl.
Uncle Daryl.
Uncle Daryl, big
You know,
contributor.
It's
He's a
present,
big source of methane on the couch.
Big source.
it's present at a lot lower concentrations than carbon dioxide, but it's about at least 30 to 70 times as powerful a greenhouse gas as carbon dioxide is.
Molecule for molecule.
Molecule per molecule. And so it's a good thing there isn't as much of it in our atmosphere. But then you go to the third one on the list, which is laughing gas. And here you're thinking, oh, dentists, right? They're making all of their patients relaxed. And
I knew it. Dentists are the source of all our problems.
The other place that you might think about with laughing gas is if you go to the store and you get some whipping cream and that little spurt that you hear on your pump when you put it on your pumpkin pie, that's laughing gas. But the real sources of it, and they're really
I'm not giving up my whipped cream. I'm sorry.
well, it's not
flood the world. Take us into it.
It's not a big contributor, but it's growing the pumpkins for your pumpkin pie that's the problem, Neil, because it's when we over apply fertilizers and bacteria in the soil end up doing nitrification and denitrification processes that turn all of that extra ammonia and nitrate urea fertilizers into laughing gas. And
So it's agriculture.
Agriculture is a big contributor, and it lasts for it's about 300 times the global warming potential of carbon dioxide molecule per molecule, and nothing happens to it in the atmosphere. It doesn't dissolve in water. It doesn't break down in chemical reactions. So it's a big player. And then the third one, the last one on that list behind carbon dioxide are the fluorinated gases, things like the CFCs and so on. You put all three of those together, and they add up to about 2/3 to 3/4 of the change that's happened to our planet's radiation balance since the Industrial Revolution. They're
So
really
you said CFCs as a chemist. Okay, you're fluent, but for everybody else, those are the chlorofluorocarbons, correct?
So it's CFCs. These are molecules that are made of carbon atoms and fluorine and chlorine atoms only. And then they've been replaced with ones that aren't as damaging to the ozone layer. But there's other fluorinated compounds too, where we put fluorine atoms on carbon. And whenever you do that, they last a long time in the atmosphere, and they absorb a huge amount of infrared radiation that would otherwise escape our planet and go into space.
So can I ask you, when you talk about methane, which is far more powerful than carbon dioxide, when we talk about losing the permafrost and you talk about the melting of glaciers, that means that we're going to have a crap load more of methane in the atmosphere, right?
Yeah.
Well, tell me about the permafrost. Let's hear that story.
So there's two places where we have a lot of methane naturally stored on our planet. And one of them, well, three places, of course, is deep underground in oil and gas fields. But we have a lot of methane stored in the permafrost up in the polar regions. And some of it's pretty deep down. And then we have methane stored in molecules that are called clathrate hydrates. They're kind of locked in cages of water molecules off of ocean shelves. And when we get to the polar regions like the Arctic, and we start seeing climate change happening, and if we get a change in temperature of a couple of degrees average around the planet, that translates into 8 to 10 degrees Celsius increase at the poles. And what happens? We start getting what Catherine talked about, a positive feedback loop. And positive doesn't mean a good thing. That the temperature warms up. It doesn't take much energy to release that methane gas. And then we get one of these feedback loops going where the methane gas powerful greenhouse gas, causes more local warming, causes more permafrost melting. And that's probably been one of the phenomena that has happened at other times in our Earth's history when we've gone through mass extinctions. We've maybe had a meteor hit the planet and release a lot of methane from clathrate hydrates.
Chuck, did you hear how casually he said that?
Yeah, exactly.
So, yeah, it's kind of happened in the past.
Our other mass extinctions. Those other things that happened.
Those things.
One time. There was a time when a meteor hit the planet. That didn't go so well.
Yeah, it's just another time. It's all right.
We used to have these things called dinosaurs. We might join them. Who knows?
Hey, but that's what makes this climate crisis so serious, right? The effect that it has on biodiversity, the effect that it has on human life, but also our whole planet's life. And we're risking entering another mass extinction because we can't seem to manage that problem of greenhouse gases.
So what's the biggest challenge? And given your chemical expertise, what are the biggest opportunities that you see in front of us to mitigate climate change?
Yeah. So the two big challenges are that the climate crisis is so serious and it's on such an urgent timeline that we feel inadequate as humans and we become paralyzed. And I think another equally big challenge is that politics has hijacked the climate conversation in really unfortunate ways. So, carbon dioxide molecules in the atmosphere don't vote conservative or liberal or Republican or Democrat. They don't respect national boundaries. And yet the gases that we emit in North America, for instance, affect life in really profound ways for people in other parts of the world who don't emit many greenhouse gases. So we've got to find ways to understand each other, to move beyond our nationalist agendas and work together to become caretakers of the planet.
Okay, so it's easy to say.
Yeah.
How are you going to make it happen?
Yeah, well, there's a little visualization that King's Center for Visualization in Science is to work over the last 2 years to create an interactive learning resource. It's called Design Our Climate. And it's something that your users can go to. It's going to encourage them to envision the future, to design future emission scenarios by making informed choices about electricity, transportation, land use, building materials. And what do you find when you do that? First of all, that if you use currently available technologies, you can get to our target of 1.5 degrees Celsius. It's tough. It requires fundamental changes. But the other thing you find is there's no silver bullet. There's not one new magic technology that we can impose that's going to make it happen. I like to say there's silver buckshot. There's a whole bunch of things that we can do, and we can do them together, and they will make a difference. So, yeah. That's a resource that I think your listeners might find pretty helpful.
I'd never heard a firearms analogy uttered by a Canadian before.
Yeah, makes sense. It's like silver, but all we have to do now is shoot climate crisis in the face. That's what we have to do.
So, what do you know about the Blue Sky Zero citizen science initiative? What is that?
Yeah, that's fantastic. This is an initiative of Pocket Lab, who's co-sponsoring this event. And Pocket Lab makes a bunch of sensors, air sensors, water sensors, instruments for citizen science. And my team at the Visualization Center up in Edmonton partnered with Pocket Lab over the last year. And we've been helping launch a program called Blue Sky Zero. Get a bunch of air quality sensors in the hands of citizens from around the world, and then see if they can measure air quality during the shutdown. And then as we emerge from the shutdown, can we actually measure significant changes in air pollutants? And so that pilot was really successful. It showed us that we can do it. We can get data back to scientists who can begin to make sense of it. And now the challenge is, can we roll out some citizen science initiatives on a much bigger scale to help all sorts of people understand and feel like they can own their understanding for some of these big challenges. So we're absolutely thrilled, Neil, to announce today on StarTalk that we're unleashing on the world a free interactive electronic resource to use to help understand what the status of our life support systems is and the extent to which human activity is threatening it. It's called the Planetary Boundaries Framework. Some of you are going to know something about it. You can
so what we see is just a frame shot, but it's actually an interactive tool.
It's a live interactive tool that went live last night at about midnight. And you can look at all 9 Earth systems. You can see how their control variables change over time. You can click on them and get a bunch of information about what you can do about them. We think it's going to be a really powerful tool to help with climate change understanding and how it's linked to all of the other Earth systems. Because climate change
It looks like an awesome teaching tool, of course.
It is, yeah.
Yes. Yeah, because then you can walk people through it, and then they become, then they can take that to others once they become sort of fluent in it.
That's right.
In what it means and where it's going to take you. So what thoughts of hope do you have for us here?
Hope, it's got to be active hope. But what brings me hope, Neil, is 2 things. I'm really privileged to work locally in a learning community. And these days, teaching chemistry, every day when I go in, I see my students with masks and face shields on, and they're trying in the middle of all of these challenges to live out our university's vision statement, which is help to build a more just, humane, and sustainable planet. And they're doing it. Our world's in good hands with these young people. But then I also work at...
That's because they're all Canadians.
Well, they're Canadians. They're nice too.
Duh. That's just that you get that for free.
But then the other thing that brings me hope is that I do a lot of work at global levels in science and science education space. And there is a lot of momentum about doing science education differently so that we think about systems. We get away from isolated facts. We think about sustainability. And so we can find ways to do science, to do education as if people matter and as if our planet matters. And that gives me a lot of hope.
Yeah, but Peter, I think that's a great perspective and thought and sentiment. But what's at the center of what you're saying is that it's not just the knowledge that something is happening. There's the understanding of why it's happening. And that requires a level of science literacy that you are championing here. Do you have hope for the world if the world does not achieve the science literacy you think they might need to really embrace the problem?
Science
and not have it just be a superficial thing that they heard about at the coffee lounge?
If chemistry keeps being taught the way it's been taught for the last 100 years, where it's a whole bunch of isolated facts that you memorize, and then it's hopeless. But that's not happening. There's fundamental change happening in science education, and it is focused on systems thinking. It's focused on sustainability, and it's a train that's moving. There's no way that train's stopping now. You see it in the next generation science standards in the U.S. You see it in science and sustainability initiatives. You see chemists and scientists working with people in the humanities and social sciences and the fine arts. We're on the train, and it's moving.
That's a very 19th century reference there, on a train. See, in astrophysics, we're on a rocket and we're going fast. Okay. Just consider using a more updated vessel for this.
But you're an astrophysicist, so you think about rockets, right? Then we're writing a children's story about getting a train over a mountain from Venice, which is flooding to Paris. And we're asking kids to think about what locomotive is going to take them there as a way of talking about it.
Okay.
So trains are in my mind. Yeah, it's Thomas the Tank Engine, told by a chemist.
Yeah, we got that. Well, Peter, thank you for this sharing this expertise. Well, we got to close out this show. This is the first ever virtual StarTalk Live. It's been fun to put together. I want to thank Chuck. Nice, Chuck.
Such a pleasure, always.
All good. Catherine Hayhoe, who did our first 2 segments. Peter Maffey. And I want to publicly thank Pocket Lab for co-sponsoring this event. So this has been a production of StarTalk. And I've been your host, Neil Degrasse Tyson, as always, bidding you to keep looking up.
With Masterclass, you can learn from the world's best minds anytime, anywhere, at your own pace. Learn how to ace your opponent from Serena. Improve your writing skills with Neil Gaiman. Learn how to negotiate with Chris Voss. All right, those were the courses I chose, but you'll have over 90 classes to make your own choice, and they're all taught by world-class instructors. Now, of course, the master instructor Dr. Neil deGrasse Tyson has a masterclass of his own on scientific thinking and communication, and we all know how important that is in these times. I'm not the only one who's benefiting from my masterclass. My brother is an avid tennis player, and I sent him the gift of a subscription so he could get schooled by Serena. Did I tell him that it was a part of my subscription? Well, let's just say the answer rhymes with ho, ho, ho. From learning how to write anything from a book to a screenplay to communicating with your boss to how to make dinner worthy of a Michelin star or just the best scrambled eggs this side of a jumpy chicken, there's a master class for you. I'm in the middle of a course on sex and communication because I'm good at one of those things. Masterclass is accessible on your phone, web, or smart TV. You can get an annual membership to Masterclass and give one to someone else for free. Get unlimited access to every Masterclass for you and a friend right now. Just go to masterclass.com/StarTalkRadio. That's masterclass.com/StarTalkRadio. Masterclass.com/StarTalkRadio.